Hi there, this is the third of my online lessons. I'm Mr. Hawkins, I'm Head of Science at Thomas More Catholic School in Purley. Today we're going to do some chemistry. We're going to have a look at how you calculate relative atomic mass and relative formula mass. So what you should get out of this tutorial is as follows. Describe what is meant by relative atomic mass, explain what is meant by relative molecular mass, also known as relative formula mass, be able to calculate the relative atomic mass and relative formula mass, and if you're looking to start A-levels next year, it'd be a good idea to look up Avogadro's constant and what a mole is. Also, if you're pushing for your GCSE 8s and 9s, you should be able to understand both of those terms. Okay, first thing I want you to do is write down the elements present and the numbers of each element in the following compounds. Off you go. You should have got the following. As you can see, I'll only go through a couple of them. The top one is sodium chloride, NaCl. What you have there in that compound, an ionic compound, you have one sodium element, one atom of sodium, and one atom of chlorine. They're bonded together. Here, in this example, you have magnesium chloride. You have one atom of magnesium and two chlorines, denoted by the small 2. Just going to jump to the bottom example. Where you have brackets present, you have to times out the brackets. So here you can see, because the 3 is on the outside of the sulfate, what you'll notice is that it's 3 times 4 oxygens to give us 12 oxygens, and it's 3 times sulfur to give us 3 sulfur atoms, and the small 2 after the aluminium denotes, like we did with chlorine, there'll be 2 aluminiums present. Now, there's a couple of rules that come out from that, and they're quite simple really, and I have already said them, is that the idea of a small number is only relevant to the number it's behind. What I mean by that is with, say, for example, chlorine, the little 2 after the chlorine means there are 2 atoms of chlorine present. The second rule is that small numbers outside of a bracket mean multiply everything inside of the bracket like you would in maths. So, for example, here the 2 goes behind the hydroxide ion, leading to here being 2 times oxygen, 2 times hydrogen. I should say that if that was hard for you, now you've heard the rules, go back and have a go again. See if you can attempt the questions and then check your answers. Make sure you understand this bit before you move on. Right, next thing I want you to do is have a look at masses. You're going to need a periodic table to do this. You can either Google a picture of one, or you may have one in your school planner, etc. What I want you to do is write down the mass of the following elements: hydrogen, oxygen, sulfur, calcium and carbon. Make sure you take notice of the key on your periodic table. Don't mix up the atomic number with the mass number. What you should have got are the following answers. Hydrogen has a mass of 1. Oxygen has a mass of 16. Sulfur, 32. Calcium, 40. Carbon has a mass of 12. Okay, so hopefully you got them right, but if you didn't, here's a quick way to check and to make sure you understand how we work this out. I've put helium atom, then I've drawn this tile using PowerPoint. Your key's probably a lot nicer than mine. But what you can see here is that the larger number is the mass number and the smaller number is the atomic number. It's like that for every example apart from hydrogen, because hydrogen has a mass of 1 and an atomic number of 1. What you need to remember from this is that the mass number includes the total mass of the nucleus, so that includes protons and neutrons. For example, here with our helium, we know it has 2 protons by having an atomic number of 2. but it also has a mass number of 4. So to work out the neutrons, you quite simply subtract the atomic number from the mass number, which means that in this case, this helium atom would have 2 neutrons and 2 protons, leading to the mass of 4. A separate thing you need to know, and if you're working out electronic configurations, remember the 288 structure for GCSE, it's slightly different at A level. But with that in mind, the atomic number also gives you the number of the electrons, providing the atom is not in its ionic form or as an ion, where it may have gained or lost electrons. So, the relative atomic mass can be referred to in the following ways. Relative atomic mass, RAM, or AR. All of these mean exactly the same thing. So that might get you thinking, well, what does relative atomic mass mean? So split it back. Go back to how you would try and work something out in English. What does the word relative mean? Have a go. Well, when I tried to write this, I thought the best way to look at this is to think about relative is a comparison. Okay, it's how you compare something to an object. I'll give you an example. I run. You wouldn't believe it looking at me, but I do run, and relatively, I am a reasonable runner. If I compare that to, say, a professional runner, I'm poor. It's how well you compare your ability. So relative allows us to compare all of the atoms to one atom, and that links, as I said earlier, to Avogadro's constant, whereby the number of particles in 1 mole is completely equal. If, as I said before, if you want to follow that up, go and have a look. So you might be thinking, that's a definition, but what does that have to do with relative atomic mass? It's probably best to look at this picture that I put together. So, looking at your periodic table, you will notice that carbon has a mass of 12. And if you compare that with hydrogen, you'll see that hydrogen, as we know, has a mass of 1. So, effectively here, these two elements would be balanced on our scales if we had 12 hydrogen atoms and 1 carbon atom. The scales would, in effect, be balanced. That's because the relative atomic mass of carbon is 12 and the relative atomic mass of hydrogen is 1. So they must be equal. So for it to balance, you'd have to have 12 hydrogens in that case. Interestingly enough, the 1 atom of the 12 grams of carbon is also equal to 1 mole. So now we move on to relative formula mass, molecular mass, or MR. This is effectively the sum of all of the relative atomic masses in a compound. So what that means is you just quite simply add up what you've done before. I'll give you an example. H2O is 2 hydrogens and 1 oxygen. So what I'd like you to do now is calculate the relative formula mass of this water molecule. You should have got the answer of 18. You get the answer by quite simply timesing the hydrogen's mass by 2, has a mass of 1, 1 times 2 is 2, plus the mass of oxygen, which is 16. So 16 plus 2 equals 18. Okay, what I'd like you to do now is to calculate the relative formula masses of the following. What I've done for you is I've given you the formula and the name of each of these substances. So have a go and then you can check your answers with mine. Here are the answers. what you should see is that effectively what I've done is where the bracket was present, I've inserted an arrow for you to show you how you calculate that. Remember your rules from maths, your bid maths or bob maths, whichever you use. You must do the calculation in the bracket first. If you've got a nice scientific calculator, if you use brackets correctly, it should do it for you. Okay, so let's pull back what we've done in this tutorial. We've worked out what is meant by relative atomic mass. We've also explained what is meant by relative molecular mass. And we've proved that we've been able to calculate the relative atomic mass and the relative formula mass. I hope that helps you get a good idea of how to how to calculate relative atomic mass, or how to calculate relative molecular mass. Any questions, feel free to comment or to share this on. Please try and practice. You can easily work out some compounds yourself and get a good feel for how to do this. My next session will probably move on to looking at the percentages and the relative abundance in each. Thank you very much.